So going back to the 15 exam scores, what we want to do is create a graph called a box plot. And the box plot 5-number summary. So this is the same data before, for which we found a 5-number summary. Let's just write that up here, where we had 31, 70, 82, 94, 100. So our box plot's really going to emphasize showing these ideas. Box plots are great for skewed data. It kind of shows more clearly where things are centered, and it will very clearly show what's actually an outlier and what isn't. So it's called a box plot. It can also be called a box and whisker plot, because there's a part of it that we call the whiskers while we're graphing. So the first thing we want to start with is just a horizontal line. So we need to start with a number line. And our box plot's going to kind of float a number line. So we create this kind of ground that's going to be below our box plot, and then we create a number line. It's kind of like what we did for the dot plot. Let's just start at 30, and then you want that consistent scale again, so 40, 50, 60, 70, 80, 90, 100. And that scale has to be consistent down there because we need this number line to show us where things are landing in relation to each other. So we can start with is the median, Q1, and Q3. Those values are going to make up the box part of our graph. So Q1 is the first line of our graph. So if we go to 70, that's going to start the box. The median is going to graph the middle of the box. So if we go to 82, and then Q3 makes the end of the box. So at 94, we'll have a line there. And then you can just connect those 3 lines, and that makes the box part of our graph. So it's always made up of Q1, median, then Q3, and then you connect them. And again, this box plot's kind of floating above this number line, just kind of give us an idea of where those are landing. Then what we need to do is have these whiskers that show kind of minimum and maximum values. However, what we want to do with box plots is if we have outliers, we want to separate them. And to do that, we look at these fences. These fences give us an idea of this kind of upper, like largest value that's okay for our data, and this lowest okay value for our data. So let's calculate the upper fence. If you take the third quartile value plus 1.5 times the interquartile range, which again, our interquartile range was 24. And this right here, this is always our formula for the upper fence. You always take your third quartile plus the 1.5 always stays the same. That's always 1.5 right there. And then times your interquartile range. Same thing for the lower fence where we take our first quartile minus and then 1.5 times the interquartile. So if we take 94 plus 1.5 times 24, that's going to give us a value of 130. So this is telling us the maximum acceptable value. If we find the lower fence, we take Q1, which is 70, minus 1.5 times 24, and that's going to give us a 34. So this is our minimum acceptable value. So what I do with this is I go back to our data, and I imagine where are these landing within our data set if it's all organized here. So 34 is above 31, so it's between those 2 numbers there. So there's our lower fence. Upper fence of 130, well, that's going to be larger than 100, so that's somewhere out here. So if we see how those fences work with our data, we can see is anything that's left outside is an outlier. 31 is just too fun, is an outlier. And that's evident from our previous graphs as well. It was pretty separated, but this, by calculating these values, that's our proof. So now that we know we have an outlier, when we go to graph, we want to show 31 as special. So if we go to 31, what we do is we just mark it with like a little star, or it can be just this separated dot. Basically, we want something that shows that it's separated from the rest of the graph. So it's not going to be connected. So once we find our outliers, then we want to draw the whiskers. So whiskers go to the minimum and the maximum values. So what we want to do is, looking at our data, the maximum value, that's our 100 right there. For our minimum, even though our 5-number summary shows our minimum was that 31, it's now been moved. You want to imagine we just kind of took it out of the data set. So our minimum value is actually 62. So what we do is we go to 62 and there, and then you connect it to the box. And then same thing with 100, it's that cutoff point there, and connect it to the box. So when figuring out these minimum and maximum values here, especially when you have outliers at work, you just think about what if you took the outlier out of the data set, and that's where you would graph. One thing, and it's very important because it's the most common mistake, never graph the fences. This number of 130 and 34, they're not actual data values. They're just these kind of invisible lines that say what's acceptable for data. So graph these numbers, only graph values from your actual data set. So what we're trying to get at here, like I said at the beginning of the videos, is the overall analysis we want to conduct is describing shape, center, spread, and any unusual features coming through. So let's start with shape. That's where we want to describe it as symmetric, left skewed, or right skewed. So looking at our box plot, we have our outlier over here, which if we kind of imagine it connected, this is a tail over here. We have this tail to the left. So that tells me the data is left skewed. So the exam scores are left skewed. And then from there, we want to describe the center and spread. And usually you describe those together. So 2 options for center, you can either talk about the mean or the median. And for us, because it's skewed data, we don't want to use the mean, because remember it's being influenced by that outlier, so we want to use the median. So the median exam score was 82 points. And then we can connect the spread, which again, standard deviation is great for symmetric data, but since it's skewed, we want to use the interquartile range. So with an interquartile range of 24 points. So we have our shape, center, spread, and then the last piece is any unusual features, and this is where we mentioned that there is an outlier. There is an outlier score of 31 points. So that's how we create a box plot and then create our conclusion describing those 4 key features of shape, center, spread, and features.